Welcome back to the second part of working group presentation. Now you will hear from the working group 3, Sustainable Space. This working group is sponsored and supported by Airbus. And from this, I would like to thank all the Airbus working team who joined us and helped our working group delegates, particularly to Ariane Bouy, Julian Viba, and Adam Vigneron. Thank you so much for all the support you gave to this working group, and I'm sure that everybody is looking forward to hear more about space, about sustainable space. I will give now the word to our first reporter to speak for his team and to tell us more about this working group.
Thank you. So, I want to present our team. It's a team from different nationalities and, of course, different backgrounds, which will have different ideas, and that's why we were able to complete like such a, such a topic with like so many different ideas. Okay, next slide. Okay, so to start with eco-design and sustainability in space, we need to talk about like some areas and tasks that like we need to make better like in the future and even now. So like these tasks and areas are like new materials and architectures, like which means like the extraction of raw materials and how to make it like a lower environmental impact. The idea of green manufacturing, like which starts with design, like digital twinning, manufacturing itself, transportation, and the production. Green systems, which means the use of itself the structure that we're like modeling, and the maintenance of this system. And at the end of the life management, we also need to talk about like the reduction of elimination of all these systems, and to start thinking about recycling in space. Next slide, please. So as I mentioned, like there is some big environmental impacts that like we sometimes don't even take into consideration. Like, and it starts with design. Like people staying at their desk for 10 years, like to design a unique mission is cool, but it really takes a lot of resources in general, like and time basically. Also, like during the production stage, the extraction of not only germanium but like other other materials for solar panels and other structures is also not very stable, let's say, like for eco-design. Also, like the testing, like it requires a high amount of energy, and like the test models like are expensive for qualifying space products. And this causes also like ozone holes due to launches and other like factory processes. The CO2 emissions from data centers and ground stations, and at the end disposal. As I said, like we need to start thinking about reusing the materials that we send to space. Next slide.
Yeah, I'll take it from here. The background and history of environmental topics or eco-design are a good starting point to discuss specific strengths and weaknesses that we in Europe have. First important strength that we as a team came up with are the open borders within the European Union and a large knowledge of the transfer of knowledge itself. So how to collaborate between different countries. As you all know, the European space community is highly interconnected, not only within itself, but also with spacefaring nations and also just space product producing nations all over the world. And we have a high experience in those kind of collaboration. And this is definitely a strength when we're talking about such a collaborative effort like eco-design. We also have a great diversity of perspectives. This is also based or comes from those interconnection between all the European countries. Because the EU is composed of a large variety of individual nations, we also have a strong experience with regard to frameworks and guidelines and how to manage those interconnections. This is also an important strength for an economical design. The European Union or ESA also holds an active role in debris management and debris management guidelines. This is a very important factor if you're talking about sustainability and ecological impacts within space, the management of all those debris flying around, and for the debris on the space side and all the stuff that is happening due to the climate crisis on Earth. We have a huge database from constellations and also from the Copernicus Sentinel program on Earth observation. So this is definitely a strength that we can use. Those data are really crucial to assess the impact of what companies and nations are doing with respect to emissions and impact on the environment as a whole. So we need the capabilities to monitor what is happening and what are the effects of what are we doing. And also, this is then the next step, if our mitigation strategy are effective and if they have a positive impact. Of course, whereas light, there's also shadow. The European Union or Europe as a whole has also some weaknesses that hinder us on our goals. One of the most important is the pretty harsh funding environment. Compared with states like the USA, it is really hard to acquire risk capital because, as you all know, space companies or space endeavors come along with huge amounts of cost and also with very long time frames and time perspectives, which makes it hard to get money from private investors. But we need the innovations from the market and we need the capital from the free capital market. So that's a thing we need to mitigate. Second point, the ununified and slow adoption of legislation and technology. Although we have on the strength side the experience with frameworks and guidelines, it usually takes a very long time within the European Union to adopt those technology and also to react on what is happening. But in order to mitigate the climate crisis and establish an effective eco-design, we don't need to react, but we need to act instead. So this is also an important frame. The frameworks we already talked about now multiple times have a downside, and that's we are on this slide. Yeah, we're on this slide. Though that they are rather strict. So those strict frameworks may also cause harm by hindering some new innovations and developments. And another important downside is the lack of governmental support. First of all, financially matter, but also that it's pretty hard to acquire funding or funding we already talked about is also plays into there, and the geo return situation, so that every country which invests money within ESA also has to get a return, leads to sometimes inefficient and ineffective transportation and logistics, which comes along with a negative environmental impact. On the next slide, we see different technologies from similar industries that can help us to use our strengths and mitigate our weaknesses. The first is minimum waste of material. For example, in the highly optimized automotive industry, the processes are highly effective and they're also trying hard to reduce waste as much as possible. This is something that the space industry should definitely do as well. Also, proactive design. That means not only to comply with the regulations because they exist and must be obeyed, but rather improve the design beyond those restrictions to have an even more positive impact and be well prepared for the future. Reduce energy consumption is a very self-explaining point, especially with respect to materials and testing facilities. The excessive testing within the space industry is a really important driver for energy consumption. Also clean fuels for all the rockets itself, obviously, and also for the processes, industrial processes that are involved in manufacturing spacecraft. Simulation and digital twins can help to reduce the testing effort by simulating certain points or reactions to the environment. This is also an important factor. Also, clean manufacturing, so that meaning less dust and less chemicals to be utilized, and recycling, of course, trying to close the product life cycle. On the next slide, we see different leverage points for the space industry specifically. First point we came up with is a platform standardization. This is also well deployed among the primes, the prime manufacturers, prime contractors within ESA. But we can extend that to the concept like the aircraft family concept that Airbus or Boeing are utilizing, to also apply this to space hardware, to have a set of platforms where you can make certain improvements or add something or leave something out, and do not have to start all over again for a new satellite. Also new surface treatment technologies that can help to lower the ecological impact. One other important point is in customized life cycle assessment, LCA. Life cycle assessment means that we look into the whole product life cycle and determine what are the ecological impacts and effects on every step along the life cycle assessment. And if we can specifically tailor such a life cycle assessment to spacecraft and to launchers, then it becomes much easier to assess and mitigate the environmental impacts. Also to integrate biomaterials like biocomposites for satellite structures. And an interesting point we came up with is carbon negativity. That means aiming to be carbon negative. So instead of producing emissions and CO2 equivalents while manufacturing, rather reducing or taking CO2 and CO2 equivalents from the air. One crazy idea we came up with was to produce synthetic fuels by electrolysis from CO2 within the atmosphere and use this fuel on a spacecraft, because by that we have taken the CO2 from the atmosphere within the fuel, and by the point we release the fuel into the vastness of space, we have effectively removed it from Earth's atmosphere. And the last point for this slide, to reuse spacecraft parts after end of life. So some of you may be familiar with the Clear Space initiative, which targets to deorbit a spacecraft, and the goal for the future could be to disassemble parts that are still usable from those spacecraft and reuse them within the orbit. So maybe bring them to some kind of logistic station and collect them there, and then build something new out of it or something like that. Yeah. And with that, I hand over to Maurice.
Thank you, Nicholas. So our next question was like, what can we do? We are students and young professionals, and we have a lot of time in the space field to go with. And what can we do now to help the sustainability in space? The first thing that we can do, we can start from here. We can start with SGAC and start with creating projects for the eco-design. These projects can be with a good focus for companies and interested people in the topic of eco-design. And we can engage more people with these projects to try to work on new ideas and new projects for the cause. Other thing is to the education outreach programs, where we can include sustainability in academic curriculums to prepare the students for to work for the sustainability in space later when they get into their careers. Other main that we can work on is hackathons. Hackathons are the main source for new ideas and innovations in different industries. So we can start as young professionals with hackathons that go for solutions and for sustainability in space and for eco design. And mentoring sessions by young professionals for the students in universities, in schools, where we can share with them the importance and the responsibility we have for the space and the environment. Next, we have we can ask questions in our work in our work projects when we are participating.
Maritz, I am afraid we have. Okay, you're back. Okay, maybe Maritz is having some connection issue. Maybe Nicholas, you can take over.
I can take it from here. Yeah.
See
So
now?
one important point for students or young professionals is ask questions. Ask questions within the company you are working in, within your university, about the economical impacts of the projects you are working on. That's the first point. Second point is raise concern. When you meet some topics in your project, so you think that's a massive waste of material. Maurice, are you back?
So
yeah, I think we hear you.
Okay, you can hear me good now?
Yes.
Okay, so the next point was to raise concerns when we see points that are polluting the environment or that are not good for the ecosystem. We can also, beside that, suggest new alternatives. We can see the alternatives that we talk about here and just introduce it to our teams. The other thing is that we can participate in related events, like this event, for example. Participation in such events raise the awareness for the ecosystems and the eco-design. Collaboration with different experts. When experts from the design team collaborate with environmental team and work on the projects from the beginning, that will make the designs of the system to be more eco-friendly from the beginning. Next is to look around and be inspired. Not just see the problem and just communicate the problem to everybody. Also, we can see the solutions from other industries, from other people, and try to invest it and implement it in our systems. The last point is to employ eco-design engineers in our teams. We can push to have eco-design engineers in our teams, in our careers. And if you can do anything of this, you just can talk about it to everybody, to your teammates, to your students, to everybody. Next are the recommendations that we had for the UN and SJC and others. We can start with the collaboration with academic institutes and space agencies to implement the new ideas. Like universities are well known for new ideas and new research all the time, and we can help them to implement their ideas in the space, which are not so risky because we are not losing a lot of money, and we are also doing it for education. Next, we can have the collaboration between ESA and the UN to create a regularly updated international standard for eco-design in space. We have a lot of regulations, and having an international standard for eco design will be very helpful. This standards should be regularly updated because we know more about the environment each day, and we have a lot to add every day. Next, we have the projects by UN and SGAC. We can use the huge space data, as we said, as Nicholas said, that we have from the constellations in space. We can use this data to work on projects to improve the eco design and prioritize the needs. We can analyze the data we get from these satellites and see which needs that we need to prioritize for now in the eco design. Next, we have courses from ESA for eco design available. These courses can be available for free for students and young professionals. These courses are very helpful for us to get more awareness about the problem. Encourage SGC project to find alternative eco-friendly materials, because we have a lot of materials in the research now to be alternatives for other impacted materials, just as SUTEX 650. These are very helpful to have projects to study these materials and how they can be helpful. And then repurposing satellites at the end of life, because we have a lot of satellites going out of their life each day, and repurposing these satellites to have different purpose and get like recycling these satellites even when they are in space is very useful. And then we have mentoring sessions from the companies for the young professionals, in which the importance of the environmental responsibility can be emphasized. And last, we can pursue and accelerate in-orbit recycling research, as I said, for the repurposing of satellites or other materials. Next, we have Cameron.
Thank you, Marit. As you can see, sustainability in space is a really broad, far-reaching topic with plenty of room for improvement. This is an extremely important decade for all global industrial activities, and aerospace is no exception. We are now on a path for 3 to 4 degrees average global temperature increase by the end of the century. It used to be 2.5 degrees, and even then we could not say what would happen beyond this tipping point, nor were we sure if we would have the technical capabilities to halt and accelerate, to halt the acceleration caused by natural feedback loops present in all interlinked natural systems. Some industries are moving more quickly than others to address this crisis. So in conclusion, we need to work together to identify neighboring industries and their leaders who are in tune with the current pace of sweeping changes required, which is dubbed as eco-leadership, and who are having a lasting positive impact on the climate crisis, which affects us all. We need to act now to secure our future in space. If we do not, space will become less accessible to us all. So with that, happy World Environment Day, everyone, and keep looking up.
Thank you so much. Thank you all for this outstanding presentation. Thank you, Marit. Thank you, Jorge. Thank you, Nicholas. Thank you, Cameron. Thank you, Gina. Thank you to all the working group. You did very nice work. And most importantly, thank again our golden sponsor, Airbus, for supporting the European Space Generation Workshop, and for supporting the working group 3, and for coming up with this topic that is a highly important, the sustainability or space sustainability. That's extremely relevant nowadays, like nicely concluded by Cameron at the end of this presentation. Guys, you made very nice work. Let me maybe ask one of you, Nicholas, how was it working in this working group? Did you enjoy it? Was it? Would you recommend it to your colleague?
Yeah, me personally, I totally enjoyed it. I think it's a great experience, and also have all the different perspectives flowing in, and yeah, merging them, fusing them into such an result is, I think, an opportunity that one should not miss.
Thank you so much. So, guys, you have a few questions. Let me start with more with the first one. We have a question. What means carbon negativity fuel? What does that mean? What is it that we can call carbon negativity fuel?
Yeah, I can elaborate on that. So if we take CO2 from the atmosphere and then use processes like electrolysis, which are fed by electricity, and this electricity comes from a clean energy source, then we can take this carbon and make fuel out of it. So fuel that contains carbon, like hydrogen or something like that. And if we burn this fuel within space, then we have removed it from atmosphere. That means carbon negative fuel, taking CO2 from the atmosphere and converting it into a fuel that can be burned within space. Instead of taking from the from fossil ones. But you can also continue on that. Cameron.
Could I also add to that? So carbon negativity as a concept is pretty straightforward. Say in the case of if you cut down a tree, you plant two. So whatever you're removing and all your collective activities summed up, if you're able to put enough back in so that at the balance sheet at the end of the day, all the sum of all of your activities are less than the impact that you had in the first place. It's been around for a while, this concept, but like I said, this is a difficult decade. Carbon neutrality is, in my opinion, is not going to be enough. We need to take one step further, overshoot that minimum mark, and aim higher, and we'll get there. So that's why carbon negativity is very, very important.
Very nice. So let me ask you a second question that you got. You mentioned several technologies that could be spun from other industries. Which one you believe would be the most promising, or which one is the most promising for you? Maritz, would you like to comment on that?
I believe the green fuels are the ones that we are already working on in these times. We are working on electric propulsion and things like that. So I guess that green fuels are the head to the start, where to start. And also like the frameworks that we have are encouraging new materials in the manufacturing. So this is the second point that is really important now.
Mm-hmm. These are maybe the prioritized technologies as well? Is this what they are prioritizing right now?
Yes, exactly. These are the ones that we started in already, and the industry started in already, and these are the priorities that we are looking for. But maybe later on, with the frameworks coming out, we would see another things to be more prioritized then.
I think also they're using eco-materials and new composites for wasting less resources on material extraction. So that is also important because it's already happening right now.
To add to that, I think it's really important to have a good mix of technologies, and I think first step is to have a good approach, like the life cycle assessment, to know what your product impacts, what the impacts are, and then you can watch or look what technologies you maybe use. But first point to start with is to be clear or be serious about the impacts that you're causing and looking into how to mitigate.
Mm-hmm. So you all worked hard on making a list of recommendations that is very valuable, but I would like to ask you the same question that we got also. Do you think, or what is it difficult for organizations to implement? What are the recommendations that you feel will be hardest for them to implement? Maybe Jorge? Or
Yeah, I'm sorry. Like, I mean,
No.
well, I mean, in general, like, I mean, sometimes it's hard, like, for some companies to implement this because, like, I mean, it costs money. You know, like, I mean, the money factor is kind of important. They need to create all this like eco design system. They need to invest on it, even though like in the future it might like be a good I don't know, like let's say investment, because you put something and you get something back also, plus you help your community. But like, I mean, not every company is not that they don't consider this. I think it's like it's complicated for them to say like, okay, I'm going to give like a part of my money, let's suppose, to something that right now like not many people is doing. So like, I mean, the more like other companies start doing it, the bigger companies that start making it, and bigger companies start asking like, I don't know, like daughter companies and stuff like that, the more that we will get all this eco design and sustainability in space, the faster. Yeah.
All right, so we are close to end. Maybe I can ask one more question that is from me, and I'm sure you are more experienced in this field than I am. So my question is, now the moon is quite accessible, let's say, and there's a lot of projects of establishing stations there. Do you think that will help the space sustainability?
It depends on how we use it. Like, I suppose like, for the moon, we really need to start thinking like beyond what we have been doing on Earth. You know, like, I mean, on Earth we started like as an experiment. We really didn't have experience. We just dropped satellites and everything that we could, like, just to try. Right now, there is not that excuse. Like when we go to the moon and we will put like satellites, bases or whatever, we need to do it like consciously. That like we need to keep it clean. And not only like, I mean, the orbits, but itself, like the moon, and separate correctly a place with like legal framework, and you know, not to commit the same mistakes that we make here, so we can then like not only like be on the moon, but like maybe go beyond. Like, I mean, that's my idea.
All right. Yeah.
I think the most important part to really gain traction on this is ISRU, in situ resource utilization, because as soon as we can start producing consumables, fuel, water, oxygen from the resources that we find on moon, this is much more efficient than bringing this stuff to towards the moon because of the gravity well. So as soon as we can start producing from resources on celestial bodies, we can save a lot of resources here on Earth.
Can I add one more thing?
Yes.
I think it's also important to, like I've said before, to take that one step further, or even several steps further. I don't think space or space travel is ever going to diminish in the long run. Once we start, we won't stop. So with that in mind, and the lessons we've learned from the gifts that we are bearing on our children and our grandchildren, how do we think far ahead enough and apply what we've learned in the last 100 years or so, and and make our presence in space and the universe in general a long-term plan that we can all work towards.
Thank you all. Thank you for this very pleasant conversation. It was a great pleasure working with you and very enthusiastic delegates. It was a pleasure working with the Airbus team. And I would like to thank particularly the organizers of the European Space Generation Workshop and my co-host, Sergio Vargas. Thank you all, and see you in the next session. Bye.
Bye, guys. Thank you.
Thank you, Sana.
Thank you.